Welcome back to linear inequalities. Last time we learned about the 5-step process to graphing linear inequalities. So we're going to pick it up where we left off and continue with this example. So we are asked to graph y is less than negative 2x plus 3. Quick reminder, and this is already in slope-intercept form. I know that's not an equal sign, but the point still stands. That is your slope in front of x, the coefficient of x. Your y-intercept is the constant being added to x, and we start with the y-intercept. So let's start by converting, which is already in that form, and now we're going to graph this. So let's go ahead. I'm going to use orange this time. You start with your y-intercept, 3. Now you're going to use your slope. I like to make my slope equal to negative 2. I like to put it over 1 because that is my rise over my run. Okay, so now I'm going to go down 2 units and to the right 1 unit. I go down 2 units to the right. I like making lots of points. You can even go in reverse. Okay, now the key is, do I make it a solid or a dotted line? Because this is not a less than or equal to sign, it is a dotted line or a dashed line, however you call it. Okay, so I'm going to go ahead and show that. I will dash my line here. Dash, 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 dash. And there we go. That shows that I do not include the values at those points. Now, that was doing the boundary check. Now I need to solve for y. That's already done in case I didn't solve for it earlier. And now I shade. Now, if I have y as less than over here, I shade below the line. Okay, so I'm going to get my orange shader. I'm going to increase the size here, and I'm going to shade below this line like this. So this is how your graph, sorry, sometimes my shading always mess up. But I want to show you, just in case you weren't able to get this and you said, well, how do you know that's below that? Let me show you. Okay, so anytime you get a point, you just think, where is below this point? So let me consider that point. Where is below that point? Down here. Okay. Where is below this point? Okay, it's down here. Where is below this point? Down here. Okay, I hope you guys see the pattern that all these points are on this side of the line. Okay, so if they're all on the same side of the line, you just shade everything on that side. So this is below the line, and so that's where we shade. Okay, quick recap, why is it below the line? Well, let's pick a point that is for sure below the line. The point 0, 0. Okay, and 0, 0 is easy because it makes it, the inputs are way easier to deal with. Okay, so if I plug in 0 for y, negative 2 times 0 for x plus 3. 0 is less than negative, 0 to negative 2 times 0 is 0 plus 3. Is 0 less than 3? Question mark. Yes, it is. Okay, so this point satisfies the inequality, as do all these points on this side. Okay, you could test all these points if you wanted to. It's unnecessary because one point is enough to prove it. Okay, and we can also do the reverse, and we could plug in a point for x and see what we get for, or we plug in one of these points. Let me show you real quick. Like we could plug in, it looks like, let's plug in this one right here. 0, 5. 0, 5. Okay, so I'm going to plug in 5 for x, or y, is less than, not equal to, negative 2 times 0 plus 3. Is 5 less than 0 plus 3? Is 5 less than 3? Question mark. No. Okay, so these points are not a part of our solution. Let's go to example 5. This one's different. We don't have a y, so we can't graph it in terms of slope-intercept form because this is a special case. So what I'm going to do is I'm going to get the x by itself by adding 3 to both sides. You don't have to be too careful with this. The only time you have to really be careful with inequalities is if you multiply or, let me make this like this, multiply or divide, you flip the sign. If you multiply or divide by a negative, you flip the sign. In this case, we're just adding, so we're good. By negative, flip sign. Okay, that's something important to keep in mind. Do not forget that. Okay, another reason why you need to know everything from all the chapters. So we simplify, we get x is less than 4. Now, x equals 4. We know what that should look like. That is a vertical line. So we're going to go ahead and graph this line. That's everywhere that x equals 4. So if we go to 1, 2, 3, 4, this is where x equals 4, and so it is a vertical line here. Is it a solid or dotted? It is a dotted because it's not equal to, so we're going to go like this. Now, our trick doesn't work like it did before because we don't have a y. Y is less than, y is greater than. So how do we know which direction? There's definitely no way to graph above or below this line because it's going up and down. So what we need to do is we need to test a point. We kind of showed how to do that in the previous example. The easiest point to test is 0, 0. So we're going to plug in 0 for x and 0 for y, and we're going to see if it makes a true statement. Okay, so we don't have a y, so we're only going to plug in for x. So is 0 less than 4, question mark? Yes, it is. So the point 0, 0 is a part of our solution set. Okay, so we are going to graph everything to the left. Now, as it turns out, we can kind of come up with our own formula for x values. We already did for y is less than, y is greater than. If it's y is less than, it's below. If it's y is greater than, it's above. For x, it's this. If it's x is less than some number, it's shading to the left. Shade left. If it's x is greater than a number, it's going to be shade right. Okay, so we shaded to the left. We included this point here. There's our dotted line. It's hard to see, but we have a dotted line there. And that represents all the values that are in our solution set. Okay, we have one more tough example. I'm going to try to do this quickly. Maybe I'll get to this example. Yeah, I'm going to get to this word problem example because you'll definitely have problems like that. Okay, so this isn't our last example, but still important. Okay, now the first thing I recognize, this is in standard form. Now, if you want, you can graph it in standard form. There's no problem with that. Or you could solve for slope-intercept form. Since you're going to have to do it anyway to shade and make it a lot easier for yourself shading, I recommend doing it in slope-intercept form and converting right away. So I'm going to do that. So the first thing I'm going to do is I'm going to subtract 3x from both sides. Once I get there, I get 2y is greater than or equal to 6 minus 3x. The y is not alone yet, so I need to divide both sides by 2. Y is greater than or equal to. Now it's by itself. Now, if I have divide by 2, I need to apply it to both this and this because 6 and 3x are not like terms. Negative 3x, I should say. So we get 6 divided by 2 is 3 minus 3 over 2x. I leave it like this, 3 over 2x, because when it comes to slope and the coefficients of x, we like it to be a fraction. That actually helps us, okay? Step 2 is graphing, so we're going to go ahead and graph this now. So I'm going to start with my y-intercept. That's my constant, not my coefficient of x, so it's 3. My coefficient is negative 3 over 2. That means I go down 3 to the right 2, rise over run. So my slope equals negative 3 over 2. That's rise and run. So I go down 3 to the right 2. I'm going to keep doing that several times to see the pattern, get an idea of where this goes. I can even go in reverse. Okay, great. Now, is it the boundary line? Is it a solid or is it a dotted line? This time we have a solid line because this is greater than or equal to. So it can equal all the points on our line. Actually not half bad. Look, I just about hit every dot exactly through. That doesn't happen very often. Got to appreciate the little things. Now, I need to decide if I'm shading above this line or if I'm shading below this line. Okay? So let's find out. Oops, I got rid of my arrow. Let's find out if I'm doing that. Now, here we look to our inequality when y is by itself. If y is greater than the value to the right over here, we shade above the line. Okay, so I'm going to get my blue and I'm going to shade above the line. Remember, if it's y is less than, then we shade below the line. So here we go. I'm shading, and this represents all of my solution sets. That wasn't half